All right, great question from a student this week about solving systems. And the student had to do this 3 different ways, which you are likely doing as well. And so here's one on solving with elimination to help you think through the process. So elimination has the word eliminate in it, right? The root at the root. And so we are eliminating a variable. That's what's happening here. And this one, it's pretty obvious what we're going to eliminate here, right? I think if once we kind of know what this means. So we have a 7y and then a negative 7y. And we know that that is going to equal 0. 7y minus 7y is 0. And so we can eliminate the y values and just figure out what the x is and go from there. So that's the strategy that we're going to use. We're going to combine these equations. So 7y minus 7y is 0. 5x minus 9x is negative 4x. 11 minus 3 is 8. Let's divide by negative 4. So we get x is negative 2. Okay, so now we know part of our answer. Remember that solutions to systems are coordinate pairs. So I'm going to put the answer here, and it's an xy pair. So think about where the negative 2 goes. Since it's x, it goes at the beginning. Now, if we had solved for y first, then we would put the negative 2 in the y spot. Okay, I erased the z that I had put over the 0 for the 7 y's because I want to be able to go back to these equations now and substitute negative 2 in to figure out what y is. I would pick the first one. You can substitute into either one, but the second one has all those negatives, and there's really no need for me to have to deal with all that if I don't have to. So I'm going to plug into the first one. So 5x plus 7y equals 11. And I know x is negative 2. So I'm going to substitute 5 times negative 2 plus 7y equals 11. All right. That is negative 10. And now I'm just solving for y. So I want to add 10 to both sides. 7y equals 21. Divide by 7, and y is 3. Okay, so that's the rest of the answer there. Negative 2, 3 is the solution to this system. Okay, that is elimination when everything's kind of straightforward and it's already set up for you. And now let's look at one where it's less straightforward. So in this one, number 4 here, we can't just automatically go, oh, those equal 0, because they don't equal 0, right? So we need to think of how we could change one of the equations so that we would be able to eliminate one of the variables. And you could do this different ways. To me, the most apparent one would be, it would be great if this was 20x, right? And then it'd be 20 minus 20 and it would be 0. Well, that would be really nice. How can I make that equal to 20x? Well, I could multiply this equation by 2. And I have to multiply the entire equation because you can't just change one part of an equation. You know that. It has to stay balanced, all that stuff, right? So to do that, I would just multiply the entire thing by 2. So 2 times 10x is 20x. 2 times negative 7y is negative 14y. And 2 times negative 25 is negative 50. And then the other equation's good. So I'm just going to write it down underneath. Okay. So now I have 20x minus 20x, 0. Yay. Negative 14y plus 8 is negative 6y. Negative 50 plus 20 is negative 30. All right. We'll divide by negative 6. And y is a positive 5. Okay. So we have part of our answer. And that is that we're getting a coordinate point, remember, for our answer. And y is the second one. So, it's an xy. So if y is 5, then the 5 goes on the right. All right. Now we do what we did last time, and we're going to go back to the original pair of equations, and we're going to substitute this y equals 5. So you can go into either one. I'm going to go to the first one. To me, that seems simpler, but they both work. It doesn't matter which one you plug into. All right, so 10x minus 7 and y is 5 equals negative 25. All right, so I have 10x minus 7 times 5 is 35. Okay, add 35 to both sides. So that's 0. I have 10x equals 35 minus 25 is 10. Well, that works out nicely. Divide by 10. X is 1. So my solution is that the coordinate point is 1, 5 for this system of equations. So if I graphed those two equations on a graph, they would intersect at the point 1, 5. That's another way of saying what the solution is. All right, I hope that helps. And remember, don't let anyone think less of you because you're young. I'll see you next time.